All right, in this video, we're going to talk about DeMoivre's theorem and the nth root, okay? So basically, the first thing we need to talk about is what it means to be written in trig form of complex numbers. So if you refer back to your complex plane, if we have it here, your x-axis is called your real axis, and this is going to refer to our a values. Oops, real axis. And this is our a. And our imaginary axis is kind of like what our y-axis was. So this is imaginary. Okay. Our angle is still going to be represented by theta. Our r value would be our radius. And then this distance here, like our y-axis would be representing our b value. Okay, so our b value is kind of like our imaginary term. All right. So this here is our standard, standard complex form of the number. If we want to convert this complex number z equals a plus bi to trig form, what that means is z is going to equal r, which is our radius, times cosine theta plus I sine theta. Okay, our a value is r cosine theta, our b is r sine theta, and remember our radius is going to come from our distance formula, which would be given the square root of a squared plus b squared. And remember that tan of theta equals b over a. So sometimes we write that as tan inverse of b over a equals theta. Okay. R is the absolute value or the modulus of z. This is also known as our magnitude. Okay. And theta is the argument of z. All right, so on this next slide here, we have two examples. I'm going to do the first one with you, and then I'm going to check for the second one with you in class, all right? There's a couple important things to remember when changing these values to trig form. The first thing is you need to graph it, the location of it, and the second thing is to make sure you're in the correct mode. All right, so as this is focusing, let's talk about our mode for a second. If our problem is written and our restrictions are in radians, we must be in radian mode. If our restrictions are in degrees, we must be in degree mode. So we're going to do the first one here together, and it should be in radian mode. So make sure that your calculators are in that mode as well. So the first thing you're going to do is you're going to kind of sketch on the graph where this would be. So since our a value is 1 and our b value is negative square root of 3, we are going to be down here in the fourth quadrant. Okay, that's going to be important when we go to find our angle. All right, so let's go ahead and find our r value first. So r is going to equal the square root of 1 squared plus negative square root of 3 squared. So r ends up being the square root of 4, which is just 2. All right. Now our second point, and I apologize for the focusing. I don't know what it's doing. Our second point, we need to find our angle. Okay. So when we do the tan inverse of negative square root of 3 over 1, in our calculator, we're going to get negative 1.04 radians. Now, our restrictions for our radians are 0 to 2 pi. So notice that this angle they gave us is here, when they gave us negative 1.04. That is the correct angle, but it's not within our restriction. So we need to add 2 pi. Make sure when you add 2 pi in your calculator that you use the pi key. So when you do that, you should get 5.236 radians. All right? And then we just kind of need to put it together. So our answer is going to be z equals 2 times the cosine of that angle plus I sine of that angle. And that's it, okay? So remember, a couple of things that are important is making sure that you're in the right mode, okay? Graphing it and making sure that you find the correct angle, and if not, you find angles equivalent to that. that are within your restriction, and then just filling it in the form. Okay. All right, so the next thing that we're going to talk about, and I would like you to try B here tonight for homework, and make sure that you are in the mode of degrees. Okay. So the next thing we need to talk about is multiplying and dividing complex numbers. So let's say that you have two complex numbers. They're both written in trig form, okay, and you are asked to multiply them together. Okay, if you are multiplying z1 times z2, you're going to multiply your r1 and your r2, and then you're going to add your angles together inside. Okay, opposed to dividing, where you divide your r values and you subtract your angles. Take a second and read over this and make sure that it really makes sense. Okay? All right. So there are two examples listed here. We are going to do number 2 this time, so we're working with degrees. The first example is the same concept, except for they're working with radians. So I want you to try example A after we do example B here. Okay? So in example B, we are finding the quotient of these two. So we want to find z1 over z2. So using the formula given to us above, I'm going to take my z1 term, or my r1 term, so that is 2 square roots of 2, and I'm going to divide it by my r2 term, which is 6. Okay, and then we have the cosine of our angle here, 135, minus my second angle, which is 300. Okay, and then we're just going to keep going, plus I sine of 135 minus 300. Okay, so now we just need to simplify this a little bit more. 2 square roots of 2 over 6 is just the square root of 2 over 3. And then we can simplify our angle. So we have the cosine of negative 165 degrees plus I sine of negative 165 degrees. Now, this angle here is okay to leave as negative 165 because we have no restrictions on what our angle needs to be. So this is okay. Now, this here, our answer would be considered trig form. If you were asked to write your answer in decimal form, all you do is multiply it out. So we would literally distribute the 2 square root of 2 over 3 and multiply that by the cosine of negative 165, and then square root of 2 over 3 and multiply it by I sine of negative 165. When you do that, you're going to get negative 0.455 minus 0.122i. So this here is our trig form, or sorry, our decimal form, and this is our trig form. Okay, make sure that you are able to write it in both methods. Okay. The last thing that we're going to talk about here is called DeMoivre's theorem. So basically what that says is z equals r times cosine theta plus I sine theta, and n is a positive integer. So we're taking this complex number written in trig form and we're taking it to a power. All right, so when we take it to a power, this is just written as the whole base to the power of n. What we're going to do is we're going to take r to the n power times cosine of n theta, so we're multiplying the angle by n, and then I sine of n theta. Okay, so I'm going to walk you through example A here, and then I'm going to let you try example B. Now, both cases, it does not matter in this instance whether you use degrees or radians unless it specifies. I'm going to go ahead and use degrees for this case. If you prefer radians, you may use radians, okay? So for example A, it says 1 plus I square roots of 3 all to the third power, okay? So first of all, we need to change that to a trig form. My apologies. Okay, so if we work through that, we need to take 1 plus the I square roots of 3 and we need to convert it to trig form. Okay, so when we do this, our R value ends up being 2. Okay, and then our angle, because the tan inverse of the square root of 3 over 1 ends up being 60 degrees. And again, you're going to need to change your mode in your calculator to degrees so that you get 60. Okay, so our value, our trig form here is going to be 2 cosine of 60 degrees plus I sine of 60 degrees. All right, now we want to take this to the third power. So we want to take z to the third power. So what we're going to do is we're going to go ahead and plug it into this formula up here and take 2 to the third times cosine of 3 times 60 degrees, that's a times, plus I sine of 3 times 60 degrees. All right, so we have z to the third equals 8 times the cosine of 180 degrees plus I sine of 180 degrees. All right, so now it's important that you remember what your cosine and your sines are. Okay, so the cosine of 180 degrees is going to be -1. So we have 8 times -1 plus I, and the sine of 180 degrees is 0. So when we multiply all of this out, we get -8 as our answer. So it's a nice, simple answer here of -8. Okay, I would like you to try B. When you try B, it looks very complicated, but it works out really nicely. You're going to get a nice answer for B. Okay, so tonight you need to do B. You also need to go back and we need to do the product of Z1 and Z2 up here in example A. And then on the previous page, you need to do example B from converting, okay? So you have 3 problems that we're going to look for tomorrow in your notes.